Okay, today we're gonna create one EKS cluster and probably we're gonna deploy one service, one with the NodePort node, another with IP cluster, and we'll see how we can access those two applications in a different ways. And probably in the end we'll create one application load balancer where you can access that service from the outside world, like through internet. So first step probably we can follow this documentation where it will show how to create a cluster and all. Once after the creation of the cluster, this is how it is going to be there. So this is the command what we use to create a cluster. There is an utility called EKS CTL. Using that we're creating, so the name of the cluster is demo cluster, and then it's going to be in region 1, sorry, east 1, and then with the two worker nodes, mean 2 max whatever the size. So here is the structure. So it created this is the one VPC whatever we created. Inside this VPC we have probably two, I mean obviously two availability zone, 1B and 1F, yeah. And then in each availability zone, one public subnet, one private subnet, one public subnet, one private subnet. So that's so this first command will take care of creation of this VPC along with whatever exists. I'll come to this EKS cluster later what it is. Currently basically I'll also come to the Bastion server or a jump server why I created. So we generally have an internet gateway, that is if you have to communicate from the outside world to or from to this public instances in the public subnet, will be using this internet gateway. Suppose any private uh, like here, let's say this EC2 instance want to talk to outside world and probably download the image from the Docker Hub or public ECR image, then you have this NAT gateway. Using this NAT gateway you can download this one. So basically inside this, I didn't get a space to draw here. We'll have a route tables which will say that how to suppose how to talk to outside, like what is the service we should be using to talk to outside. Now we'll see the same structure in the AWS console to show like what is the VPC and then subnets, etc. So now I'm here at my console. So if I go and check here VPC, I'll probably first show the cluster and from there we'll go there. So this is the EKS cluster got created. So if I just go and check here, this is the demo cluster. If you go to this networking, here you have this VPC. This is the VPC created using that EKS util command. So see here whatever I just explained here. So there are four subnets, and then in each availability zone, one public and then one private. One public, one private. These are the route tables I said, right? If you take for the public subnet, and if you see the route table for the public subnet, you will see internet gateway as the target basically. How to open this? Yeah. So if you see internet gateway, yeah. So IGW internet gateway, that what created. If you see, that's the internet gateway. See, you can directly check here. You don't need to go there. Same way for the private subnet. If you see, this is a private subnet. This is a routing table, right? So that is connected to NAT gateway. Same thing for this one. If you see, this also have a NAT gateway. Where is this? Yeah, see, this is NAT gateway. So this is the whole structure. And if you see here, since we created two worker nodes we wanted, right? Probably we can do for the cost perspective for the POCs, we can choose the Fargate also. But now to explain this one, I created two worker nodes. So if you see, each worker node created in two private subnet. That's what if you see, right? Generally we don't keep these applications in a public subnet. So the whatever work nodes created, that would have been there in these two private subnet, one in each in one availability zone. If you come here, I'm going there to the VKS cluster again. These are the nodes, right? So if you go to this resources, yeah, these are the two nodes. I'll just go there and I'll show probably in the EC2. instances. So directly I'll go to the EC2. So if you see EC2 instance is running, uh, it's coming a bit slow. Yeah, yeah. This is the one created in 1B and 1F. Same what I just explained here, right? One in 1B and one in 1F. Two got created here. So the Bastion server, I'll tell you why I created also, right? So I wanted to show the how this cluster IP mode and NodePort IP mode works with NodePort service type works, right? So since these are in the private subnet, these are all in private subnet, right? So I'm from outside, like my laptop is here, right? I can't directly access this private thing, right? So what I need to do, I need to get into, so this is a public subnet, right? So I have an access. So whatever the instances create in this public subnet, you get a public IP address basically. So I'll get from my laptop, I'll get into this server, the jump server or Bastion server. You from this one I can talk because these are all there in the same VPC. So these two can talk. These two can talk. Suppose if you create another EC2 instance here, this can talk. For instance, one more EC2 instance if I create, this can also talk. Whatever there inside a VPC, though these all everything gets a one private IP address basically, not a public one. Whatever present here, right? So in this server, whatever I created, right, this will have one public IP address. Since I asked to create this as a public one, this also will have one private IP. So using private IP, I can talk to this, I can talk to this, and this also can talk to this, and this also can talk to all this internal communication can work. You can think how it is there, right? That's one of the route tables also here. I'll go to that route table. If you see by default there is a local, uh, if I come here, this is the one route table. If you see, this is a common one, right? Attached for that. See, this is the local. In this range, basically, probably I'll make another video like what is the cider range and all. For now, you can say this is a cider range. So, in this cider range, basically it's a range of IP addresses, like set of IP addresses. So all these IP addresses can be communicated with each other. That's what it says. Okay. So now we have all set, like we have cluster created and everything there with this structure whatever present now. Uh, so now we'll see that what is the node port mode and what is the cluster IP mode. Generally, so here, right, I'll just draw one diagram here. So in a EKS cluster, like uh, whatever we create, right, I'm taking this as directly EKS cluster. I'll probably take an example. Let's assume that this is EKS cluster. This is EKS cluster. This is EKS cluster, and I'm not trying. I'm not again keeping one more like subnets and all here. What is happening? For simplicity sake, I'm not. Yeah. So here this is an EKS cluster. Let's say we have all worker nodes span across, like let's say there are multiple worker nodes here, like span across different availability zones. Let's say these are two worker nodes, and this is a EKS cluster. EKS cluster. So here, whenever the right, basically we have a deployment file we'll be creating. Deployment file which in turn triggers pod, and deployment you will explore through service here. and later I'll come to ingress part when we expose publicly. For now, like you know this flow, right? Service, deployment, and part. This service, as I was saying, it can be of three types generally. One is node port, another one is cluster IP, and other one is load balancer type. Now we'll see the difference. By default is a cluster IP one. So whenever you deploy in the service.yaml file, you need to choose one of the type, basically either node port, cluster, or load balancer. Whatever the type you choose, cluster IP is the default one. You're going to get it. Later you are going to if you select a node port, you're going to get a node port availability cluster IP. Suppose if you select load balancer plus cluster IP. So now we'll deploy one service with cluster IP, one with a node port, and I'll show what is the difference between these two. Okay, so let's go and take in my GitHub profile, it's already there. So this is the Node.js logger. So I already deployed. So if you see here, so this is a deployment. Deployment is going to take a container from my GitHub public repository. So I just created one Node.js service. What it will do is it will just take a input, and it will store it will store inside its file system. If you just give hello, it will store inside file system. Just simple basic image and running on Node.js. So and then if you see this service, basically service is of type, if I don't mention anything here, it basically a cluster IP mode. I didn't mention anything, this is a cluster IP mode, the default one. So and this service I map to the deployment. How this is through, like using this selectors, right? So it will look for the node service logger, and it see selector app node service logger, right? It will look for the match label selectors, right? So sorry, not this one, service, yeah, this is a metadata, yeah, this metadata I look for node service logger. So that is what is it's mapping. So ingress part I'll come later. For this one you don't need. I already applied this kubectlf. So this is the command basically. So probably I'll apply one more time. This is it's game ingress instead of game ingress. Yeah, it's already unchanged because nothing is there. So now if I go and check, basically this is created in a namespace called game 2048. In that namespace it's created. So now if I go and check kubectl all and game 2048, sorry. uh, there is a spacing. So you're gonna get everything whatever created here. Come on. So here if you see, it created the service. Basically this is a service it's created. This is for two or different things, let's not worry about it. And this is a deployment, and pods it didn't come. Probably I'll show the pods also. Kubectl get pods and game 2048. think I don't know if I some reason I'm missing this come to battle command all the time. Yeah. So if you see, this is the two replica count basically I used in the deployment, and then two nodes has come up. So let me put it in O wide, so it will you will see that. So this is a pod IP. You don't need to worry about pod IP basically. So every pod gets an IP. We don't generally deal with the pod IPs basically. But eventually, in which worker node it got created, it will show. So 235. We have two EC2 instances worker nodes. Right? It is running on one of these things. So now, if I just queue services basically, right? Service is of type, as I was saying, it is one of these types, right? So NodePort or ClusterIP. This is basically ClusterIP by default, whatever created ClusterIP. What ClusterIP meaning is, definitely you can't accept this access this one from outside of the this one. You can access only inside a cluster. What it means is, so here you have a cluster, right? So inside this cluster only, if any, is meaning that from this inside this worker node only you can accept it. It is not that if let's say this is I have created one more EC2 instance here, like this one Bastion server is there. From here I'll not be able to access because it is not in the cluster. Though it is same in the same VPC, will not be able to access. Forget about the different subnet. Even in the same subnet, I'll just go and create one more EC2 instance. Probably it will be in the same subnet, but it is not part of EKS cluster. I will not be able to access. So I'll be able to access only from this ones. So what I'll do here is, uh, I'll get into another pod. Whatever here in this worker node, there are other pods running, right? I'll get into this pod. From there, I'll try to access this service using a work cluster IP mode. What I'm meaning is, so I'll get into this one. So this is in one of these nodes basically, right? I'll get into this one using interactive mode. I need to give a namespace also. Yeah, now we are here. So I'll just go and do a curl. I'm using a curl. Hope curl is already installed, I believe. So this is the IP cluster IP. What is the cluster IP for this one? So this is the cluster IP, and this is the cluster port basically 80. So and then my this one take log. Let's say hello from cluster. So content logged successfully. If you really want to go and check what this is, right? So I'll just one of these pods basically this must be present. So I'll just go here. I mean, I'll come out of this one. This is basically cluster IP, meaning that you can't access from this one. Similarly, I can get into another instance. Now we logged into one, like started 7, right? Probably the this one I can get into the same thing and I can access from the cluster IP. So this is not useful, right? Because we want this service to be available at least in the VP private subnet or eventually to the public one, right? So this is not useful. So just for the showing, right, like how whether it worked or not, like I'll just get into this pod. One fast. It is a different AMI type, we don't. Yeah, so now you're here, pw2. Now if I just go cd space logs, so cd space logs, and now I am at app.log. Okay, this is the health URL, it keeps logging in, and probably we might, that might be logged into other one, another pod we have, right? It must be here. See, hello from cluster. This is sample one. Basically, I have a health URL. It will keep a check. Basically, that's what it is doing. So this is a cluster IP mode. Now the no other one is like a node port, right? So if you go and check here the service one, what are the services we have here? So this we check the cluster IP, so you can access. This is the node port one. So I should be able to access, as I said, I should be able to access from here also, right? Like from a node port is, if I have access to this one using this cluster IP, so this cluster IP will get a port basically, not the sorry, not cluster. This worker node has, let's say, one IP address, right? That IP address, that port number. You are getting a port on top of node, that's called a node port. So this can be accessed anywhere from the VPC. Whoever has access to this worker nodes, right? They can all access. So probably what we'll do, we'll get into this Bastion server, and from here we'll try to access. Or else you can log into this one of these nodes also. Basically, to log into these nodes, we can't directly log in, right? We'll what we'll do is, first we'll get into this one. We'll directly try to access from here, and we'll also from here to here we'll get into this one, and I'll track access the node port. Similarly, same thing. So this is the node port. This is the node port you have, and 32493 is the port. So now let me go to get me what do you call log into the Bastion server here. Think I have this Bastion. Hope I think this is the same one. I have that same IP, I believe, but let's see. Yeah, now I'm into 192.168.52, right? This is the public IP EC2 35 172 121.6. If you go and check here in this one, so I'm at EC2. So this is the Bastion server, as I said. So it has a public IP where you can access directly from my terminal. 35 172 121.69, right? 35 171 and then the private IP 192.60.52. So this is a private IP. Now inside you are there inside this one, right? Now let's try to access directly from here, right? This is a cluster. This is the 32493. Now we need a IP address of this worker node. Will so this will be available in both nodes basically. Let me take that IP, right? So what is the IP of this one? Private IP we need. There is the private IP here. I'll copy this 235. I think I'm not sure if the same thing. No, I think this 235 and then 192. Let me see if it's the same thing. I copied some time back. Where are we? Okay. Okay, I think these are the same thing. So these are the IP address. 235 is one of the private IP, and the other one you have a different IP basically. So now this will be accessed on this port basically. So what I'll do, I'll just go and do a call on this one. So for this one, this is a different service basically, right? It won't accept. This is a basically one gaming application. This is HTML page. That's why you should see some HTML content here, not the logger one. So I'll directly do a curl from here. So this is the node IP and this is a node port, whatever we got it here. So sorry, curl. See, this is a it's working basically from here. So directly from here, now we tried. Directly from here we tried. Now we'll get into this one of the nodes and we'll try that. So I already copied even to log into this node, right? You can't directly access though they are in same VPC, right? So while creating of this one, I gave one private key pair. So and same private key pair, and I copied to this one before this demo. Basically, I copied this whatever the private key from my local to Bastion and Bastion to this one. This is what the command basically. So this is the copying, right? So from my local I copied here to the public one. From here now I have this private key present in the Bastion server. From Bastion server, using this one, I'll connect to this uh, basically the private instance. So where is this one? So I'm gonna clear here. So if I just log into here, I think I should have one of these commands. Yeah, here. So if you see 192.168.78.10, that is one. This is a private key. This is the private instance, right? 192.168. I think maybe with this is a different EC2 instance. Let's see. One fast. Yeah, 192.168.78.10. So now I log into that one. So now I'm here on it. So now from here we'll try to do a curl. See if I this is to the same one we can do, and or else like we'll try to the different IP, different node basically. So what I'll do now, I'm here, right? I'll try to do a different node IP basically. We have this is one of the node IP 178. We are in this one. Now we'll do this one. So it worked. So basically now if you see here, whatever this one, from this we are able to access, from this we are able to access. If it is a cluster IP, it should be inside a cluster. Now basically I logged into the worker node, but it is not a what do you call, it's not into cluster basically, right? This is just another, it can be any EC2 instance. I am not into the cluster and still I'm able to access it. Now these are all good. Basically now what you did, you are able to access inside a pod. From here you try to do that, and directly uh, uh, that is during the with the cluster IP mode. Now with the other mode, basically with this node port one, I try to access this in here. Now somebody who is sitting here public, right? You want to access that one. That's where the ingress comes into picture. So here basically you have an ingress here. So ingress sitting here, uh, yeah, ingress will come here. Ingress, what it will do, so once you deploy ingress based on a routing, probably I'll show with a demo that will be more useful, more explanatory basically. So if I go and check here, basically I'll show with this one other application, right? So I said like in the later I'll show this ingress part, right? So here this is a ingress, and then it is a health check I was saying, right, at that time, like it will for continuous it will go and check whether the health is up or not. That's what it's sample one is being lagged. So it is a ingress class of ALB. So on the now if I deploy, yeah, since I already deployed this file, you should see the ingress file also here. I'm coming out of this one. So kubectl get ingress namespace game 2048, right? So if you see, yeah, so this is a ingress it's running, right? So this is basically ingress one. So ingress is the moment you deploy ingress, right? Basically it is of no use basically. So uh, what happens basically in the EKS cluster is, so so you have a ingress here, you have a ingress here, so which will say routing basically. Suppose if it comes on this log, forward it to this service. We have service and then deployment and then pod basically, right? So this is, it will go route to this service. Suppose if there is another instead of log store something comes, move it to different service, something like that it will be there. So ingress of no use, somebody has to uh, forward route these ones, right? There is a ingress control. There are multiple things in things in a market like ingress controls. There is by default out of the box ALB ingress controller, and then Nginx, more popular Nginx ingress controller. It is. So now we are going to do the out of the box ALB ingress control. What it will do is basically it will keep checking whenever the ingress comes, right? So the moment you deploy this ALB ingress control, this ALB ingress control nothing but a pod basically. So you are going to do a deployment, apply a deployment which will spin up pods basically. This pod, uh, this pod is responsible for uh, creating ALB. Here you should get a doubt basically. So you are creating pod where? So this is where you are creating a pod, right? The pod will be created inside one of these worker nodes. One of these worker nodes. So in this VPC, you have outside basically here, let's say one AWS service. Thus ALB is here, right? Or let's say S3 or anything. In this case, basically ALB. This is one of the AWS services. Right? You want this pod to go and create AWS service basically, right? So what is authentication? Do you think that any pod in this one will go and create any AWS service? Now it's basically ALB control. Tomorrow, suppose I want to upload a file to S3 bucket, right? Do you think directly it will come? There should be some authentication mechanism, right? This is where this OADC concept comes into picture. I want to cover that before I go to ALB. So I can just simply tell that okay, ALB ingress control will create, and if using ALB URL, you can directly call it. It's all done basically. That's all already done. So since I'll show that first basically, then I'll come to background how it is working. So that will be that ALB controller I used basically, that's publicly available ALB controller, right? This is the command what I had created is, so you can read this one basically what I was saying, right? And it's ingress control unless we install ingress controller, ingress of no use basically. This keeps checking the and it will route the traffic. This is the I'll come to this part. Basically what I did is where is that? I already created a ingress controller. So this ingress controller, if you see kubectl get pods, those will be created in a kube system, in kube system namespace. Kube system kubectl get pods. So if these are the load balancer controllers. So these are the load balancer controllers being created. So in this load balancer controllers, I mean that's what like it will go and create the ALB. So this is the ALB created, right? I'll just take this one. This is a publicly available. You can use it from your mobile also, whatever that, right? So I'm just using here HTTP and this one log hello from internet. See, content logged successfully. So this is already logged. So now it's publicly available. So what happened? This ingress, this is the flow right here. So I called ALB. I called ALB that routed to ingress. Inside ingress, if you see, this is where the configuration of ingress, if you see, where is this Node.js logger? So ingress log to route log and to this service basically. So this service, and then that service uh, the service eventually routes request to pod. If you want, you can see this also here at the live here. This is a cluster, and then where is that ALB is whatever created, right? So this is the load balancer created. I need to oh. So this is the load balancer created. Sorry, the other one. So this is the load balancer created. So if you see, yeah, this is the ingress rule. If log it will come to this target group. We have two parts basically. It will be forward to this two part. That's the map. So this is the ALB. Now coming back to this our original thing, right? How did anything in this pod. Basically, this controller is the one who created the whatever the ALB controller is the one who created this ALB, right? How it created. Same thing for the ALB tomorrow. If somebody wants to access S3 or anything, we should this should talk to AWS services, right? So here is what like OADC comes in. OADC is like OpenID connector. So whenever you create an EKS cluster by default, this will be created. That OADC URL will be created. If you see, it should be somewhere here. Security. Sorry, I'm at load balancer. If I just go to cluster here, yeah, this is the OpenID OADC URL, right? This is what created. So generally, how this authentication all works is this may be a lengthy video, but like it's really helpful for understanding how this authentication and all works. So let's say this is a AWS uh, resource. Now it's in our case it's ALB. So pod inside this EKS cluster is trying to create this ALB. How what it will do is basically, right, since this uh, OADC is there, so basically every pod runs with a something called a service account. If you don't define anything, by default it will create a default service account. But while creating this uh, ALB, I created a service account also and associated that service account to this pod. I created one service account and then I associate. That's what I mentioned here in the GitHub. You can just go and read this one. Um, I created all this documentation. That's what it says basically. I associated that to this one. So this OADC basically what it will do is it will service account. Let's say if it has to talk to AWS resource, OADC will give its unique token for each service ID basically. So then what it will do when this pod has to communicate with any AWS resource, it will go and give this token to this OADC provider. Here it's a IAM OADC provider. So what IAM generally what it will give, right? To create this ALB, I need some role to be, right? So there are multiple IAM roles created. Okay, so let's say one to access S3, one to create ALB, all those things, right? There are multiple IAM roles. So this service account has to assume one of these IAM roles, and then it should be able to create any AWS service or talk to any AWS service, right? So what it has to do, so the token whatever we got, this OADC token, right? What IAM authentication service will do, it will not generally validate whether the token is validated or not, right? Token, what it will do, this token is given by this OADC provider or not. This because in OADC would have already created by creation of EKS cluster. All IAM authentication will do is, okay, this service account something is trying to assume my role, but he is also coming with a token. So basically the action the pod will perform behind the scenes STS web identity. Okay, STS dot web identity. So while making this call internally, what it will do, it will also give the token along with whatever the IAM role it wants to assume. So both it will give. So then IAM service will do, okay, so this guy wants to assume this IAM role. He sent a token. Is this token really given by the OADC or not? Then only I'll allow this guy to assume this role. Then once you assume this role, this ALB will create it tomorrow. Some this pod wants to upload a files to S3. This I'll allow. There is another IAM role that I'll allow to assume that role so that he can upload a files to S3 bucket. Now you may get a doubt. How IAM role will know that? Okay, there should be some configuration, right? So IAM role, what I just said is IAM role is going to verify this token is given by this guy or not, right? So now in this case, if you see this service account whatever I created here, this is the namespace it's going to create a service account, AWS load balance service controller. This is a service account. It is, sorry, so this is the service account, and it is trying to assume a role of this one IAM EKS load balancer control. Now let's go and see how this will know, this role will know that okay, I should allow this service account to assume this role or not. Okay, I'll go here inside this IAM. So so this is a trust relationship. This is what, this is a federated one, right? This is the OADC provider, whatever we saw in the EKS clusters one. So and this is the, if you see, load balancer controller is the service account. That is what it is trying to assume. Load balancer. Where is that? AWS load balancer control. This is this service account trying to assume them. So it will go and check. Okay, this is the one. Whenever uh, it is assume role with web identity is being done by this service account, meaning that when this condition equals to this one, then you are allowing that service account to assume this role basically. That is what happening behind the scenes. So because you added this one, okay, so now the service account is able to talk to any AWS service and created ALB. Similarly, if some you want to isolate like this some of the part trying to upload a file to S3 bucket. So what you need to do, suppose for that to upload a file to S3 bucket, probably you need a different IAM role, right? That IAM role needs to be assumed by this service account, let's say. So what you'll go, you'll go to that IAM role. In that trusted location, you're going to trust that service account basically, and then see that okay, whatever this service account given a token that is given by this. uh, OADC provider or not. That is what it is doing. I think hope it makes sense. Just to summarize basically, right? I think what we have done here. So we created a cluster, and then we created cluster with two worker nodes, and then so we tried a node group mode, and then we tried cluster IP mode, and also we created and while trying basically we verified that cluster IP and then the NodePort mode by logging into the servers and all, and we also created a ALB using that ALB ingress, and we directly access through public subnet also. Sorry, from the outside internet world also. I think hope it makes sense. Yeah, thank you.